estimative. Basically, like it should be like you should sample maybe the least probable samples / tokens, but you should keep the sentence fluent. So how should we define the creativity in LLMs?
Yeah, so thanks for that question. So basically, I don't know if you saw, but one of the things that I showed is the impact of temperature. And so this is exactly what temperature is doing. If you're increasing the temperature of your LLM, now you'll be sampling from a wider distribution. So you're changing the next most probable words. And so you'll be going further away from the most deterministic. If you put your temperature at 0, you'll be using just simply the most probable next token. And so we asked, what happens to our creativity test if we run our prompts on different temperatures, so from low to mid to high? And indeed, we see that if you increase the temperature, the creativity goes higher. So this is in line with what you're suggesting. And also the other thing is that the way that the LLM is responding to our prompt is that the prompt is really to try and find words that are different in meaning from one another across 10 words. So all the pairs within the 10. And so it turns out that by trying to apply this, as opposed to just taking 10 random words, the divergent procedure that is happening within the LLM seems to mimic, and I say mimic, it's not exactly the same cognitive process that humans are doing, but it mimics what happens in humans when they're trying to find words that are maximally distant from one another. The LLM is not actually computing those distances. It is not being told to go and if you can have reasoning systems that might crack the code of the test and say, I know I need to go and measure semantic distances and do a lookup table or something. But that's not what's happening. It's actually responding to a prompt that is asking for words that are different from one another in terms of their meaning. And there's more in the paper, so I can send you the paper, but there's more in the paper where we explore different other things that can impact the creativity. For example, asking it to use etymology of the word or asking it to use opposites. So we did a number of things like this to see. And also the other thing is that if you increase the temperature way too high, it will not be complying anymore to the prompt because it will start answering randomly. So this is also part of your question. We need to increase the temperature, but not too much so that it still understands what is asked to do.
I see, thanks.
Is there other questions?
And Shukri?
Yes, Shukri?
Not
I think there was a question by Iman before, but
yes.
Yes, hello everybody. Thank you very much for this presentation, for the inspiring presentation. So my first question is the same than the previous participants about your definition of creativity. Why this question? So I am research and didactics of mathematics, and my first interest is in cognition, and more precisely in psychological cognition. So, and my interest in neuroscience is related to my new interest on AI. So, it's often claimed that the transformer architecture is inspired by a neuronal mechanism in the human brain. So, ANN, artificial neuronal network. So in neuroscience, the model and the background, the theoretical background of neuroscience only describes information processing and does not explain or anticipate the cognitive process itself. That's why to date, as long as I know, there is no mathematical model that fully describes or predicts GenAI's internal behavior or reasoning between brackets. So how can we talk about creativity when we have no information about the cognitive process of the development of the tokens?
Okay, yeah. So there's a lot to unpack. I will say briefly so that I agree, first of all, that we would need more mathematical understanding of the basis of AI in general, actually. AI is actually moving faster than a lot of things that we do in other fields. So it is borrowing terms from neuroscience, sometimes vaguely. We talk about attention in transformers. It's not necessarily the way neuroscientists think about attention in many cases. Same thing for memory, same thing for consciousness, and so on and so forth. So we are borrowing terms. The field is moving because it's powered by compute and powered by huge amounts of data and by algorithms that are actually producing things that are of interest to solve a wide range of questions. They are not always, and probably most of the time, not acting the way the human brain acts, right? So and because they're powered with a lot of data and algorithms that we sometimes don't really understand how they are working, at least not in detail, not in mathematical detail. That's why I think there is agreement that more mathematics into the functioning of AI is needed to understand them better. Now, it seems sometimes like an engineering approach where sometimes for many of the questions we have, for example, even using back propagation is something that there's a lot of debates whether can be something similar is implemented on the brain or not. But at the end of the day, for many applications, people are saying from the computer science side, well, we don't really care if that's what's happening in the brain. If it solves our problem, that's great. This is why I mentioned this as like an engineering approach, and I was also trained myself as an engineer. Sometimes you want something that works for your solution, and then you might want to understand why it's working. And so back to your last question about cognition and the fact that we're not actually identifying the cognitive process itself for creativity, I agree. This is like saying we can use models and we can build planes that can fly. They're not flying the way birds are flying. We can have output that seems creative, that scores creatively from Gen AI, that is not using the same mechanisms that humans might use for generating creative outputs. So the summary of all of this is, well, at the end of the day, it's just going to depend how you are defining your concept of creativity. Are you looking at something human creativity and you want to understand exactly how that's unfolding, or you are judging something by the outputs of generating an idea, generating an image, generating a solution to a problem, or even a solution to a mathematical problem. There's a lot of research now using AI to solve mathematical problems that are still unsolved. Would more creative algorithms come up with solutions faster? I don't know. So this is an active and exciting field, to summarize.
Salut.
Yes, thank you very much.
Thank you for your question.
Salut, sir.
Yeah, oui.
Je peux poser mon question en français?
Bien sûr, bien sûr, bien sûr.
Merci, monsieur. On connaît tout que l'intelligence artificielle est basée sur les équations de son pondéré. Donc, on perd presque beaucoup des informations lors de l'apprentissage. Donc, si on parle de l'apprentissage cognitif, comment atteindre un modèle d'intelligence artificielle ne perd pas de l'information, mais nous sommes basés l'heure de l'entraînement à une formule mathématique qui perd des détails.
Bon, je dois dire...
Sorry, Karim, can you translate this question in English and give the answer in English, please? Please. Thank you.
You're giving me a good task.
Ok. Je comprends l'anglais, mais un peu pour discuter. Je comprends.
It's just for the other people. Huh?
Yes.
Okay.
Yeah, so who wants to translate that question?
I can try. Okay, Shukri asked for the training task. You have to minimize the cost function to optimize the weights on the neural network, for example. And in this process, we can lose a part of the data. And if I understand, the question is, how can we reduce this loss? Okay, how we can improve the mathematical models to reduce these
the loss for more information.
But okay.
Yeah, I mean, the short answer.
It's not a simple question.
The short answer to that is I don't know. The long answer is I don't know at all. So yeah, I think it's an interesting question, but we have not worked on that, and so as a general rule, I prefer not to just invent answers if I don't have them. So yeah, I think it's an interesting question, Shukri. I don't know.
Thank.
Okay, I think there is another someone who the name is the name of the computer, Asus.
Rajay, Nabil, so that's me. I think Rajay.
Rajay. Hello, Rajay.
Aslima.
Okay, go on, Rajay. Aslam.
عايش merci. First, I want to thank our speaker. It's really a great tour of lots of interesting and amazing questions. So I will not pretend that I grasped everything that he really talked about. But I do have something that kind of comes back, and I would like to hear Mr. Jerbi's perspective on this. There is something that we tend to believe. We'd like to always create, not create, but really believe a story, link the dots. We're really now even making storytelling as an art of great speakers, of great leaders. So when we look at the outcome of an LLM, algorithm, and sometimes it looks coherent, yet we make the story and we fill in the blanks and we kind of want to believe also. So I want to hear your perspective on this aspect of us humans being lazy mentally, maybe, and trying to be comfortable with whatever story we would like to believe.
Excellent
am I
question,
making
Rajay.
sense? I just want to know,
Yeah.
this touches probably on creativity or the lack of it, or on the variation of population and the profiles. So احكي لنا شوية. I mean, I'm curious to hear your perspective on this. خاطر I know احنا as Tunisians, at least, I mean, I might be biased, but I heard this from a great
We are not just
scientist,
Tunisians in this group,
scientist.
Rajay.
I know, no. Oh, I'm sorry about that. I'm just
There
saying
is
that there
some
was
Saudi
one
colleagues
observation about different
also.
cultures, and there are some societies, they have the art of storytelling. So it's a great feature to be recognized in some cultures and more than others. So how does that come into in the work or the research that you've been doing? And if you can, bring that link, what would you tell us?
Okay, so merci. This is really an interesting question, and I think it touches upon multiple aspects of what we consider to be sense making, what we consider to be storytelling, and how our brain is wired to make sense of the world. And it does touch, I think it does link to creativity. But I would say, I think first of all, by design, our mind always tries to make sense of of the information that it receives. And so partly because it has these predictive models, we are constantly predicting the next milliseconds. And so we're expecting things to happen. As long as those things happen, everything makes sense. If something all of a sudden diverges from that, we try to still fit it in. So we change the narrative to make sense of the environment. This is also why these things happen also during dream. And so the brain is, in a way, functions as to protect us from being shocked at every millisecond. We're always predicting, we have an idea, and then if things follow suit, then everything's okay. But as soon as, so for example, if you're walking in the street and all of a sudden you're looking at the tree, but then the tree disappears, that makes no sense. Your brain is going to have an error signal that's going to tell you this makes absolutely no sense. Well, what you might start doing at that point is, oh, maybe I'm dreaming. So you're going to again try to make sense of the thing. Oh, maybe this is just a dream, so that's okay. And so you start making sense of the environment. So we do fill in the blanks, as you say. We do it a lot with many things. If you listen to music and you have a video that goes with the music, sometimes you're going to find it even more powerful. That's why video clips have had so much success, because it's not that they're well tuned. Sometimes it's just more or less random, but your brain likes to build the relationship between the sound, the music, and the images, the video, and the information. And you all of a sudden you're creating your own narrative of why these things make sense, that this type of music is happening while you're watching this type of images and so on. So we do fill the blanks all the time. This is by design how our brain works. Now, storytelling is a very nice, I think, thing to consider. Across different cultures, storytelling has played different roles. I am lucky enough to have a nice collaboration with a team of scientists, researchers, and creatives from indigenous backgrounds, indigenous communities across Canada and the US and Maori and elsewhere, Hawaiian, where the objective is try to rethink about AI through the perspective of indigenous epistemologies, broadening the definition of AI. In general, we have the impression that this is something humans are sometimes very arrogant. We think we've understood human intelligence, so now we want to build it in machines. But then when you think about it a bit, you realize, well, have we really understood what human intelligence is before we can decide that this is what we want to build? What we end up building is a very rudimentary, sometimes Western-centric, Eurocentric idea of what intelligence is, and then we want to have that to be implemented in a machine. For certain applications that might work very well, but globally it can also have biases, it can also have harmful impact. So there is a push to exploring intelligence in a wider sense. And in this context, in particular in the context of indigenous communities and indigenous epistemologies, storytelling, to get back to your question, is fundamental. There's a lot of knowledge that is also given through or shared through storytelling. There's a lot of culture that is embedded in storytelling. And so examining how humans generate stories, what this tells us about humans is one thing, but then also exploring how is that reflected in AI? And it does not mean that AI will not be capable of generating stories in the same way, because again, we're just talking about a machine that learns statistical information from huge amounts of data. So if it sees a variety, and it has to be wide and diverse storytelling material, it might also have some capacities to generate storytelling in ways similar to how humans do. But generally, your topic requires like much more of a deeper, maybe a panel discussion or something with different perspectives. We need to hear from people from different domains, I think, on this notion. But I think it's a very interesting question to consider. I hope I gave you some answers in my response.
Thank you. I am listening to your wonderful story. Definitely. I mean, we hope that you can come one day and we get to listen more, or get more into what you presented. I know it's very brief, it's really high level, but let's, hope we'll talk with Nabil. Maybe we can get you to visit us and tell us more in details about these wonderful, amazing stories of linking the human with the artificial. And it's just incredible. So I want to thank you again. I'm just happy with and comfortable with all this ambiguity also. So it's
Good.
great. Thank you.
Thank you, Raja.
Other questions?
I see there are questions. There's Nuha, I think. Is that the next one, maybe?
Yes,
Nuha.
yes. Nuha al-Mulla.
Nuha. Yes,
So the
Nuha.
question, shall I read it, or is Nuha connected?
Nuha, you are still here?
Yes, salam alaikum. Hello,
Wa alaikum
everyone.
salam.
Yeah, nice
Salam.
meeting you, Dr. Nabil and Al-Khwarizmi. And this is my short question. If you can share your thoughts, Prof. Karim, about prayers 5 times a day. I think it's interesting to study. What do you think?
Okay, so this is slightly outside of my domain, but I will say there is quite some research indeed that is exploring different forms of practices that involve, let's say, spiritual approaches. Because also, as you know, meditation, the original forms of meditation that come from the Far East, they are by design also spiritual. So they involve also forms of spiritual components. In many approaches in the West, people have taken the meditation and have stripped it away from the spiritual component and say, let's look at this as a cognitive exercise of just training the attention, for instance. And can that by itself be helpful? It turns out that it does. But there's also the whole field of exploring combining the spiritual with the cognitive processes. I do not know of any studies that have looked in detail. I'm sure they exist, but looking at, for example, the impact of prayer, actually across all religions, be it Islamic or others, I think there are some researchers and research groups that are exploring the effect on cognition and on the brain also of that. So it is a continuum, but at least for now, the research that we've done with our collaborators has not included the spiritual component. But I think it's an interesting question.
Thank you.
Thanks,
Okay,
Noha.
thank you. Okay, if we don't have other question, perhaps we can stop this webinar. Thank you, Karim.
Yeah, there was just one quick comment, I think, by Stabrak about the multimodality and how it constrains
Yes.
creativity. But so, yeah, I'm not quite sure. Do you mean multimodality like visual and language combined in the training and things like that?
Yes.
Yes. So we are looking at VLMs currently. So I think we might have more information on that soon. We are looking at a phenomenon
What is
called pareidolia.
VLM, Karim? V for
visual, yeah. Basically
visual.
yeah.
Okay.
Yeah, like language and models, but also visual. Sometimes they're trained separately and then combined afterwards for inference, but sometimes they're actually trained together. So there are different ways of approaching these. But yeah, I think we don't know enough about that yet, but also we don't really know what is the best way to measure. So we have one way to measure now the creativity, which is the DAT, but that is one component. It's the divergent component. But for sure, there's going to be an impact of this. And again, at the end of the day, it depends why you're using this tool and what you want to do with it. I think creativity at large is sort of a vague concept. Creativity in solving mathematical problems is not the same as creativity in training a robot with reinforcement learning approaches that are more creative. It's not the same thing as generating images or generating music or generating a video. So I think at some point we will have very specific formulations of creativity that are going to be domain specific potentially.
Okay, thanks.
Welcome.
Okay, no other questions?
There's one post by Shukri.
Yes,
sorry,
I see.
if all artificial intelligence, if all artificial intelligence based on neural networks relies on the fundamental mathematical formula, and if this formula mainly optimizes data, how can we speak about cognitive artificial intelligence when its real foundation is only mathematical optimization? Well, I think this is, again, like similar to Rajesh's question, this is a very wide question that we can explore from many angles. The brain is really good at doing optimization. Actually, I think our brain is one of the best optimizers that we still have not managed to mimic with AI. It is very efficient. It can do one-shot learning. It can also solve complex tasks with minimal energy, which clearly is not something we can say about current AI that is consuming a lot of energy and compute. So there might be things which in our brain that we can potentially represent with as forms of mathematical optimizations, maybe a combination of different mathematical optimizations. And the fact that these systems learn from data, I would also argue that's what our brain does. We also learn from data from day one or from day zero. We're getting a lot of data that is being processed, and then we're also learning from being embodied. So we interact with the world. And this is one of the things that has been missing in AI, but is now catching up. We have world models that are being presented, and as a lot of people believe that world models are going to be super interesting, in particular in the field of robotics and reinforcement learning. But in general, the idea of having a system that interacts with the world is going to give even more data and even more feedback on the way they interact with the world. And so they might learn more sometimes from this interaction than actually from its pre-training of some of these models. So I to summarize, Shukri, I think it's not very surprising. We can imagine that humans learn from a lot of data. Human brains do a lot of forms of optimization. And there might be some similarities there. It does not mean that they're identical because, again, we can reach similar outputs with different methods. And we see this again in the typical example of planes fly. They don't use the methodology used by birds, but there is still flight in both cases. So I think there's a lot of things there.
Okay, thank you, Karim. Thank you for accepting our invitation. And we hope we can invite you in Tunis.
Inshallah.
And if you come back for you are really welcome at the.
Yeah, I would love that. It would be nice to organize an event together. Yeah.
Okay,
sure.
okay, you are welcome. You are welcome.
Thank
Merci
you.
encore une fois. Thank you everybody for attending this webinar, and see you perhaps next year.
Yes.
Next season.
Good.
Okay, it's the last conference for this year.
Good. Yes, Nabil. With this talk, we conclude this academic year's webinar series. I would like to thank you, to thank all of you for your participation and valuable contributions throughout this the year. I wish you all a wonderful, relaxing, and well-deserved summer break. We look forward to seeing you again the next season, starting in this September with our first talk to be delivered by our colleague, Professor Nabil Gmati, from Lamsin, Tunis. Until then, enjoy your holidays and stay safe. We look forward to welcoming you back in the new academic year. Thank you very much.
Thank you very much.
Okay, bye bye. Merci Karim, à bientôt.
Merci, à bientôt.